Hey guys, this is question 11 off your study guide. We've got a ball rolling at a speed of 3 meters per second off a table that's 1.2 meters above the ground. So this would look like this. So it's rolling off the table. It's going to go down like that onto the ground. So ultimately, we are wanting to find how far on the floor it's going to be from the edge of the table. So we're looking for this right here. So that'd be dx because it's a distance and it's horizontal. All right. So let's create your table first and fill in what we know. So we've got our x and y. We've got a, d, t, vi, and vf. So it tells us the ball is going 3 meters per second across the table. So your initial velocity is just horizontal, and that's 3. Because it's just rolling along the table. Table ends, ball keeps going, gravity causes it to go to the ground. So initially it has no vertical velocity. It starts going to the ground because gravity makes everything go to the ground. So our initial vertical velocity is 0. We also know our acceleration, since we're ignoring air resistance and all of these. That's 0, and then gravity is negative 9.8 meters per second squared, as long as we are on Earth. And then for our height of our table, the height of the table is 1.2 meters. However, the ball's going down, so we're going to put a negative in front of that to signify that it's going down to the ground. All right. In order to find dx, we don't have enough information right now in the x column to use any of our formulas. We can, however, use our y column to find time, because time is going to be the same in both columns. So we're going to use everyone's favorite distance formula in the vertical. So that's our formula. And we are going to plug in everything that we know. So we've got 0 times time plus 1/2 negative 9.8 times t squared. Anything times 0 is canceled out. Also, let me plug in our distance. So we're 1/2 times negative 9.8 is simplified to negative 4.9 t squared, and that's equal to negative 1.2. All right. We'll divide both sides by negative 4.9. That would leave us with 0.24 over here, and that's equal to t squared. All right. The last thing you're going to do is square root both sides to just get the time. That's going to square root to 0.49 equals t. Right. A common mistake here would be that people leave this 1.2 positive because it's giving it to you initially as a positive number. What that would create is this 0.24 would be negative. Right here, that would end up making this a negative number, and when you try and square root that in the calculator, it's going to give you an error message, because technically when you square root negative numbers, it turns them into imaginary numbers, and we don't work with those in physics because they're not real. All right. So anyway, that's your time, is 0.49, and that goes, why is this messing up? 0.49 in both columns. All right. So you can use that to find the rest of it. All right. To find your distance. My app is being really slow, guys. So let me erase some of this so we can have room to work out the rest of it. So you're going to use your distance formula again to find your horizontal distance. Alright, so we're going to take our distance formula, but this time in the horizontal. So VIX times time plus 1/2 AXT squared. Your acceleration is 0, so all that cancels out, so I'm not even going to bother filling it in. We're going to take our initial velocity of 3, times it by 0.49. That is going to give us an answer of 1.47 meters. Alright, so the last part's pretty easy. Alright, so to recap, we filled out our chart with what we know. We used the y information and our distance formula to find our time, because our time is the same in both columns. So then we could use that time to find our horizontal distance, because all we want to do is multiply our initial velocity times our time. So that got us our answer. So just let me know if you have any questions about it.